systems. In this course, we'll discuss about two types of systems. One is called a continuous time system, and simply we write CT system. It is a continuous time system. We have a system. Input is a continuous time signal, and output is another continuous time signal. This is called a continuous time system. There is one input signal, one output signal. And similarly, discrete time system, xn is the input and yn is the output. Okay, when we talk about systems, generally this is the standard notation. X is used to denote the input signal, and y, the output is denoted by y. Okay, so we'll discuss some properties of these systems. First property is the memory of the system. Okay, memory of the system. A system is said to be memoryless or instantaneous system if the output, this is the relation, okay, this is the relation between the input and output. This is the pictorial representation of that, and most of the time I'll be using this notation xt to yt. That means it is a system. Xt is the input to the system and yt is the output of that system. Okay, now a system is said to be memoryless or instantaneous system if the output at any instant of time depends only on the value of if the output of this system at any instant of time depends only on the value of the input at that particular instant of time, then we can say that the system is memoryless. Let us consider an example. A simple example is an amplifier. Simple example, this is the input is xt and the output is 2xt. This is the output of that system, 2xt. So it is an amplifier. Is it a memoryless system or system with memory? If you consider any time instant, let's say t naught, what is the output at that instant of time? Yt naught. It is 2 into xt naught, isn't it? It depends only on the input at that particular instant of time. We are considering output at a particular instant t naught. It depends only on the input signal value at that particular instant of time. No other values of the input. This is called an instant. This is called this is called a memoryless or instantaneous system. Such systems are called memoryless system or instantaneous system. Now, what about this? Suppose xt and the output is xt plus 3. Is it a memoryless system? It is a memoryless system. Take any instant of time, the output depends only on the value of the input signal at that particular instant of time. Second property that is also related to the memory of the system, that property is called the causality. Causality property means if the output a system is said to be causal if the output at any instant of time that depends only on the past and present values of the input. That means it should not depend on the future value of the input signal. Okay, then we can say that the system is a causal system. If the output at any instant of time that depends only on the past value or the past, it depends only on the past values or the present value of the input and not on the future values, then it is a causal system. We call it a causal system. Let us consider an example. What about this integrator? Is it a causal system or non-causal system? Is it a causal system or non-causal system?
Causal
It is a causal system because the output depends only on the past and present values, isn't it? It is not depending on the future values of the input system, of the input signal. So this is a causal system. What about this? Xt to xt plus 3. This is an instantaneous system or memoryless system. This is also a causal system, isn't it? It depends only on the present value and not on the future values. So this is also a causal system. So can we say that all the instantaneous systems are causal systems? Is it true? All the instantaneous system, if you consider any instantaneous system, is it a causal system? Instantaneous system means what?
Yes, sir.
It is the
Yes, sir.
value of that output at a particular instant of time only. So it won't depend on the future values. So it is all the instantaneous systems are causal systems. Now, can you give example of a non-causal system? Let us take example of a discrete time system. All these properties are applicable to discrete time systems also. But I'll take examples of continuous time systems. Now let us consider example of a discrete time system. We have a discrete time system xn. Xn is the input to the system and the output is, let's say, this is the output yn. It is a function of n. Can you tell me what does this do, this system? You have an input sequence, let's say some sequence. This is 0, 1, -1. What is the output at this point? Correspond at this instant of time. What is y0? This is y. What is the output at this instant of time? 0. No, tell me the operation. Is it the average of these three? When n is 0, this is summation from -1 to, sorry, is it, yeah, n is 0. Yeah, when n is 0, it is summation from -1 to 1. That means, is it the sum of these three? Okay, let me consider this example. It is divided by 3. Okay. The reason why I'm taking, what is the reason for dividing by 3? Then it is the average of these three values, isn't it? Is it? At any instant of time, it is the average of the present value, the previous value, and the next value. Is it that?
Yes, sir.
This is called a moving average system because if you consider the output at 1, then this is the average of these three values. Let's say if these three values, isn't it? So it is called a moving average system. Okay. Is it a causal system or non-causal system? Moving.
Non-causal.
It is non-causal because the output at any instant of time. So we can simply write this as yn is xn plus xn, sorry, xn plus 1. Is this the system? If you are giving xn as the input, this is the output yn. Xn minus 1, this is the previous value. This is the next future value. Next value. Okay. So this is the system. So at any instant of time n, it depends on the value at n plus 1, next value also. So this is not a causal system. It is a non-causal system. Any other example of a non-causal system? What about this system? xt to x2t. Is it a causal system or non-causal system? Is this a causal system or non-causal? It is non-causal. What is the reason? It depends on the future value. For example, if you consider y1, this is yt. What is y1? Is x2t, isn't it? It is a future value. We are considering time instant 1, and the output at that instant of time depends on future value. With respect to this 1, this 2 is a future value, isn't it? Value of the signal at 2. Now, what about this? Is it a causal system or non-causal system?
Causal system.
Causal system.
Non-causal.
It is a non-causal system. What is the reason?
For negative.
For negative values, if you consider, let's say, y minus 2 is a x of minus 1, isn't it? This is a future value. This is future value, isn't it? With respect to this minus 2. So this is a non-causal system. What about this? Time reflection. Is it a causal system or no? Huh? It is again non-causal system, because if you consider negative values, this will be positive. Y minus 1 is x1, isn't it? So it's a non-causal system. Okay, next property is the time invariance property. Time invariance means, suppose we have a system. Let's consider a continuous time system, and let's say we are giving an input signal. Say 0, 1, and we are getting some output. Or let's say like this. If this is the input, it is getting an output like this. Now, when we design a system, we should design a system such that if you give an input today, we are getting an output like this, and tomorrow also, if we are giving the same input, we should get the same output, isn't it? When you design a system, then the parameters of that system must be invariant of time. That means if we are delaying the signal, this is what? Is it a delayed version of the signal?
Yes.
Then if the output is also delayed identically, that means if it is, I am delaying by 3, so if the output is also the same signal, but it is also delayed by 3, then we call it a time invariant system. Then the system is called time invariant. Okay, it is called a time invariant system. So how can we write it mathematically? Like what? When can we say that a system is time invariant? If we are given a system xt, and let's say the corresponding output is yt. Now, if we are delaying that input, then let us say this is another input we are giving x1t, and we are getting some output signal y1t. When can we say that this is a time invariant system? Input is a delayed version of this, delayed by t naught. And when can we say that it is a time invariant system? The output is also delayed by the same amount. The shape of the signal is the same, it is only delay, time delay. Then we can say that it is a time invariant system. Is it? Okay, now let us consider a few examples. Let us start with, is it a time varying system or time invariant system? Is it a time varying system or time invariant system? Sorry? It is time invariant, because if you are delaying xt minus t naught, so what is the system? System is, it is an amplifier. Whatever the input you are giving to the system, it is amplified by a factor of 2. If xt minus t naught is the input to the system, what will be the output? It is 2 times the input signal, is it? 2xt minus t naught. Now, how to verify whether it is a time invariant system or not? It is delayed by t naught. If you delay this signal by the same amount, that means replace t with t minus t naught, you will get 2xt minus t naught. These two are same, isn't it? So it is a time invariant system. Now, what about this system? Is it a time varying system or time invariant system?
Variant.
Variant or invariant?
So time varies.
Time varying.
Variant.
Okay. Let us consider a special case of this. Suppose this is xt. Let's say 0, 2. What will be the output? What is this system? What does it do? This system? xt to x2t. That means what? Whatever input you are giving, the output is a compressed version of the signal, is it? It is compressed by a factor of 2. So if you are giving this as the input signal, what will be the output signal? Is it this? 0, 1, 1? Is it this? Now if I am delaying this, delaying by 1, what is the output signal? What is the output signal? Whatever input you are giving, the output is a compressed version of the input signal. So if this is the input, what is the system output? What is the compressed version of this?
1 by 2 divided.
It is 1 by 2 to 3 by 2. It is compressed by a factor of 2. So here we are shifting the signal right by 1. So is it a shifted version of this? This we are getting by shifting by 1, isn't it? So if you shift this right by 1, what will you get? Is it this? Oh, sorry, 1, 2. Are they same? They are same or not? No. So it is a time. If they are same, then it is time invariant. So this is, they are not same. So it is a time varying system. It is time varying system. It is time varying system. Okay. Now, how can we prove this? This I have proved with an example. Now, how can we prove this mathematically? The system is, if xt is the input to the system, output is x2t. Now, if x2 t minus t naught is the input, what will be the output? What does it do? Compression means, what is that mathematical operation? Compression by a factor of 2 means you have to replace t by 2t. That is the compression operation, isn't it?
Yes, sir.
Whatever the input you are giving, output is a compressed version of that signal. Compression by a factor of 2. That operation is t replace t with 2t. So what will be the output corresponding to this? Is it x2t minus t naught? Is it that?
Yes.
Sorry? Minus t? Are you saying minus 2t naught? No. Because the
No, sir.
compression operation is replace the independent variable with 2t. Here t is the independent variable. Replace t with 2t. That is the compression operation. So this is the output signal. Now, is it a delayed version of this? If you delay this by t naught, what is that operation? If you want to delay a signal by t naught, what is the operation? You have to replace t with what?
T minus 2.
T minus t naught. So
2t naught.
what 2t naught? No, I am just writing that operation. Replace t with t minus 2 naught. So what will be the delayed version of this signal?
minus 2t.
xt 2t minus 2t naught. These two are not the same. That is what we have proved here with an example. So this is a time varying system. Now let us consider another example. Now what about this system if we are giving xt, the output yt is xt for, let's say, t greater than or equal to 0 and minus xt. Let's say this is a system. So what does it do, the system? If xt is the input to the system, for the positive values of t, the system does nothing. It is exactly the same as the input. Now for the negative values of t, what does it do? xt, for positive values of t, output is same as the input signal. For negative values of t, it is minus of xt. So can we say that what the system is doing is xt multiplied with a function like this? Is it this? Is it that? Yes or no? If this is xt, any input signal xt, it is multiplied with a function like this. What is this called, this function? This is called a signum function. Anyway, we'll discuss about that later on. This is called a signum function. For positive values of t, it is the same, and negative values, it is multiplied by -1. Okay, let us consider an example. Let's say if you are giving this as the input to the system, this is xt. What will be the output? What will be the output?
So the negative part will be flipped.
Negative part will be, is it this? Is it the output signal?
Yes.
Forget about the discontinuity. This is the output signal, is it? For positive part, the output is same as the, for positive values of t, the output is same as the input signal, and for the negative values of t, it is negative of that. Now, is it a time varying system or time invariant system? Is it a time varying system or time invariant system? Now, suppose if I am delaying, let's say this is 1, -1, 1. So this is 1, -1. Suppose I am delaying it by 1. What will be the output? This is 0, 1, 2. Is it this? Is it a delayed version of this?
No, sir.
No. So is it a time varying system or time invariant system?
Time varying.
It is a time varying system. System is time variant. Is it? Now how can we prove it mathematically? The system is xt to xt for t, let's say, greater than or equal to 0, and minus xt for t less than 0. Now if we are giving xt minus t naught as the input, what will be the output? What will be the output? What is the expression for the output signal? What is that system doing? Whatever is the input to the signal, for positive values of t, it is keeping the same input signal, and for negative values of t, it is multiplying with -1. That is what the system is doing. Is it?
Yes, sir.
Now, if you are giving xt minus t naught as the input, what is the output?
xt minus t naught for t greater than 0.
For
T
t,
greater than equal to T naught.
what t
Greater than t naught.
why t naught? This is the input signal. So if the input signal, the output is same for t greater than 0, isn't it? Why is it t naught? if you consider, let's say this is x1t, you are giving an input x1t. What will be the output? Whatever is the input for the positive values, it is keeping the same, and negative values, it is multiplying with -1. If x1t is the input, what will be the output? Is it x1t for t greater than or equal to 0 and minus x1t for t less than 0? Is it the system output?
Yes.
Now you simply replace with this xt minus t naught. Can we say that if xt minus t naught is the input, the output is xt minus t naught for t greater than or equal to 0 and minus xt minus t naught for t less than 0? Is it? Whatever input you are giving for positive values of t, it is the same input signal. For negative values of t, that input is multiplied with -1. That is what the system is doing. Is it? Now, how to prove it is a time varying system? If xt is the input, output is xt for t greater than or equal to 0 and minus xt for t less than 0. Okay, this is the output t less than 0. Now, let's say this is output yt. xt, we are getting an output yt, that is this. Now, what is the delayed version of this? Yt minus t naught. If we delay this yt, what will you get? What is the delay operation? What is the delay operation? Is it replace t with t minus t naught? Is it the delay operation? Is it that?
Yes.
What is time delay operation? If t is the independent variable, replace t with t minus t naught. Then you will get, oh sorry, this is yt2, yt minus t naught. Replace t with t minus t naught. Now, what is the delayed version of this? This is equal to what? xt minus t naught for which values of t?
T greater than T naught.
It is t minus t naught greater than or equal to 0. What is the reason? The operation is replace t with t minus t naught everywhere in that expression. That is the time delay operation. Replace the independent variable t with t minus t naught. So here also you have to replace, and then minus xt minus t naught for t minus t naught less than 0. Is it that?
Yes.
So are they same? Are they same? This one. Here you can see that here this will remain t. Here it is t minus t naught. That's why it is not. It is a time varying system. Okay. Okay, we'll consider more examples of this time varying system, this property in the tutorial. There are many problems related to this.
Sir, once can explain that x of 2t.
Do you have a class after this? It's already late, isn't it? Which one you want me to explain? Which part?
X of 2t, the big variable.
X of xt to x of 2t. This one.
Yes.
Okay. This is the system. Whatever is the input to the system, output is a compressed version of the input signal. That means that what the system does is replace t with 2t. Is it that? That is the compression operation. So if you are giving a delayed version of the input signal, what will be the output? What is the compressed version? It is x 2t minus t naught. Replace t with 2t. That is what the system does. Now, if you delay this by t naught, what is that operation? Delay by t naught means replace t with t minus t naught. Is it the operation?
Yes, sir.
Now what is the output? It is x 2t minus,
2t minus 2.
they are not the same. So it is a time varying system. Okay?
Thank you, sir.
Okay.